Hello everyone, happy Friday and thanks for joining to this webinar. In this webinar, I'm going to talk about data modeling for time schedules and duration. And particularly, I'm going to take you through to some example about the store working hours. Waiting to more people to just join to our webinar. Okay, just a quick introduction of myself. My name is Ali Sharifi. I'm a Microsoft BI consultant. I'm also Power BI and DAX trainer. I'm founder and director at Cloud BI, when we provide BI training and consultancy. This event is hosted by Agile Analytics. Many thanks to my good friend Iman Iftikhari. If you don't know him, Iman is a co-founder of Power BI meetup in Sydney. If you haven't joined to this meetup, it's quite useful, and they provide monthly meetup. It's very interesting and good event. Okay, so this is the agenda for this webinar. What I'm going to do, so I'm going to start modeling different scenario for a store working hours via DAX. First, we go with the very simple scenario when, let's say, every store can have the fixed hours every day. Then we will include non-trading days. After that, we will look into the overriding for specific days. Then we will go make it harder. We will go to weekly schedule, and then weekly schedule when the weekly schedule changing over time. And then at the end of the session, we have about 5 minutes for Q&A. So please, if you got any question during the presentation, just post your question in Q&A section. Okay, so the first thing that we need to know is what is time schedule and duration data, and why they are some sort of the specific. This kind of the data, actually they are some sort of the rules or contract when they defines value over time. So we can have different sample for this data. For example, a store business hours, or employee working days and shift. For example, at the moment we are in the pandemic and many stores using the online delivery, so they need to plan for the capacity. Or another example in bus and train trips. The common attribute of this data is there is no pre-existing transactional fact table, same as the normal data that we have for the modeling, same as sales or inventory. And also, no event actually is happening to make a data. All we are talking about the schedule and contract and rules over the time. And what should I mention that this concept is completely different from the time intelligent concept that we have in DAX and Power BI. Yes, so we will go to some example of the store working hours. Okay. The first scenario is when, let's say, the simple one, when let's say, suppose that all of the store are open every day with some fixed hours. That's it. For example, the store are open 12 hours every day. For this one, because it's too simple, we have, for example, two tables, one for a store and one for date. And there is no natural link between these two tables. So. We will go for every scenario, we will go to the different solution that we can have and at the end, we will decide what solution actually working better and is based on the best practice. The first solution for calculating the count rows for the every day, so it's using the very simple measure. So let's say if we just multiply the count rows of the store then to the count rows of the day, by this one we will get the number of the working days for the stores. And because there is, I know that there is no link between these two tables, but when we are using them in a visual, the filter context will through to the tables and give the right number for that one. And then when we multiply by 12 that we have used as the default working hours, it's giving us the right working hours. So let me to just go and create this measure. For saving the time, I have stored all of the DAX query in a Word file. I just need to go and copy and paste them in the measure. So this measure can be on any of the tables. So we will choose a store table for that. Okay, and by creating a simple table visual, I already created some slicer, store code and date. Okay, first we get the error because there is no link with them and there is no measure. But if I just bring the measure that I created now, so you should be able to see 12 hours for each store and for each day, and you will get the right value as the aggregated and total. Okay, so that was the first solution. Let's see what other option do we have for implementing that. The second solution is we create a calculated table to make a Cartesian product of a store and date and use it as a bridge table. If you just think about the relation between a store and date regarding the working hours, so we can think about a many-to-many relationship between a store and date. One store can have multiple working hours as multiple days working hours, and one date can be used for different stores. So there is a many-to-many, and if we create a bridge table, and in the bridge table, if we have the working hours, in this way we can use the sum of these working hours for our purpose. For creating the measure table, we can create a calculated column, and the main function that we can use here is using generate. Yeah. So generate function is create the same as the cross join in SQL. It's create a Cartesian product of those two tables. So we created the Cartesian product by using the generate, and then we use the select column to just choose those columns that we need. So we just need to have date and a store code, and we will give them the different working dates and the store code. And after that, we use add column to add another column with the 12 hours as a default. Let me to copy the code. Okay. We go to the new table. And just paste this code. As a result, I should have my new table here. Then I need to go and link this table. I've created some helper table that later we will use it for the other scenario, but this is the table that we created. Just need to link to the store code by store code and working day to day. Then this is the bridge table now. If I go to the visual and by adding just the implicit measure, just a column using as a sum, so we can see we could replicate the same number, same as the measure, and we got the same value as total. Okay, that's great. So we could implement this with the two solution. Second scenario is including non-trading days. So imagine that some store can be closed in some nominated days. For example, here you can see a store 101. We can say it is closed on 1st of January, and for example, it is closed on 25th of January. And we can have the different date for the other store as well. Let's see how we can implement this. So this should any store and date in this non-trading days should be excluded and subtracted from the total hours count that we have in the model. For the first solution that we have used, that was measure, what we can do, we can simply, first we need to, if you wanted to go to this solution, we need to link non-trading days table to the two tables, store and date, to enable the filter context to go to this table when we are selecting date or store. After that, if we subtract the count rows of non-trading days from this multiplication, it will exclude those non-trading days from the result. Okay, so let's grab the formula. And replacing. Okay, so we got the minus 48 because we still haven't linked the table. This is non-trading days, and just need to go and link it quickly. Double checking the linkage, that's good. Now you can see in the visual, so we have 0 on 1st of January for 101, and also on 25th of January as well. If we go more for 102, we should be able to see more non-trading days here, and you can see the number has been subtracted from the total one. Okay, so that was the first solution. In the second solution that we used the bridge table using the calculated table, if you wanted to exclude the non-trading days, what we can do, we can use except function here. So in except function, it's excluding the second table. It needs to have two table parameters. And it's working the way that the second table, that it is non-trading days, in our example, is get excluded from the first one. So by this one, we are excluding non-trading days from the bridge table. And that should give us the same result that we have. Okay. Okay, so now I just applied the except, and yeah. So you can see here we have blank for the non-trading days for the store. So whenever we have 0 in the first solution, we have blank for the second one, and the total are same. For this scenario, we can have another solution. So we still can use the bridge table, but instead of implementing everything in the calculated table, so we can use a bridge table and create calculated column to that. So the first calculated column, so we can create a new column, call it is non-trading days, that give us that it's a store during that day belong to the non-trading days or no. So for that one, we simply can first calculate the values of the non-trading days with any column. It can be a store code or date, for example. And then inside the calculate, we just need to filter non-trading days based on the raw values that we have for this store and working days in the bridge table. And after that, we have if outside of this calculation that tells us that this row of the bridge table is belong to the non-trading days or no. And after that, we can create another calculated table, calculated column, sorry, for working hours. So we call it working hours CC. That here we just simply can say that if the is non-trading days is yes, then use 0, otherwise use 12 as a default one. And also we need to, the same as the second solution, because this is the bridge table, we need to link this to a store and date. Yeah. Let's go and quickly implement that one. So I'm taking you to the different options that we have for answering this question. So another new table. Call it store working hour days calculated column. Just have the 2 column, working days and store code. And then we are going to create the 2 calculated column. Okay, so you know that when you create a calculated column, so when you are processing the model, it gets calculated and will stay as a normal column in the table. Okay, so this one, we go to show you over here. Yeah, we have this one, and if I filter by this one, you can see by this column, you should be able to see those non-trading days here. And then the other column, the main column that we wanted to use for working hour, another new column here. And just paste it. So okay, you can see here we have 0 for that. Just let me remove the filter, clear all the filter, say that, and now we will get to the table visual. And if I add the new columns that we created here, we should see that the aggregated value, but because we haven't linked that yet, so I'm going to bring the new table in. Yeah, just to mention again that in a real scenario, you don't need to implement all of this. So you will go to just one of the options, and based on that, You just need to link one of these tables. So code and working days. Hopefully this time. Yeah, we got the right value here, so it's all calm. And for the non-trading days, here we have the 0 as well. Okay, that was the second scenario. Let's go for the third scenario. In this scenario, we will include override days. So let's say for some particular days, the store manager, they wanted to change the working hour specifically for one store for 1 day, for example. So this data can come as a table. For example, here we have for 2nd of January, a store 101. Instead of the 12 hours, they wanted it to be open for 8 hours. And for example, on 5th of January, it's going to be open for 16 hours, and so on for the other store. Okay, let's see how we can, in this case, so the data for this table get more priority than the default working hours. Good. If you wanted to go with the measured one, what we can do, we need to first link the working hours to the store and date tables to enable the filter context. And after that, same as what we did for non-trading days, we can subtract controls of the working hours override table from the multiplication, but we need to add some of the working hours override to the results to just replace the default one with the override one. Let's go to this scenario, the code. Okay. So now you can see, sorry, we still haven't linked that. Just every time I forget this. Okay, so this one, yeah, that's our table. I need a bit more space. Let's put this in the middle and into a storyboard and link date to date. Just checking the link the right columns. Okay, now let's see here for the 2nd of January, we have 8 hours that came from the override table, and for 5th we have 16 that came from override table. And if we go down, we should be able to see some other column, other rows for the other store as well. Yeah, for example, for 102 we have 10 hours. Implementing this override table to the calculated table is a bit tricky. Let's say if I think most of you are familiar with using left join in SQL queries. If this is similar, so we wanted to left join the main table to the override table. If the join was successful, could get the row from the override table, we will use the override value. Otherwise, we will use a default value. In DAX, we have a function for using the left join. It's called natural left outer join. that similarly accept two tables as the parameters, and this joining the table based on those column from each table that they have similar name, and also they need to have similar data type. Okay, so you can see here. Let me to first go and implement it for you, because this one limitation here that I need to explain you about this limitation, and the trick need to overcome on this limitation. This is our table. First, what I do, I will use a variable, call it R1, result1, and store the result set of this multiplication, the main, the bridge table here. Then if I and then you already have it. Okay, so here I have used natural left join. The first table would come from the result with working date and store code. The second table is coming from the override table. So we have working date and store code with similar name and similar data type, and then we have these two working over as a default that is coming from the above with 12, and this coming from the table. If I accept this one, if I want to save this, I will get an error. The error saying that the column that have been used, they have different data type or they have data lineage. So here we have the same data type. The problem is data lineage. The limitation that exists in natural left join, if you use any columns or any table or variable, any table function in the natural left, and if the data coming from the other table is mean that has the data lineage to the other table. For example, here we have the result set 1, but the data originally came from the date and the store. So working dates and a store code has data lineage to date and a store table, and the engine cannot handle it. So what we need to do for overcome this, we need to break the data lineage by adding some expression that doesn't change the value. For example, here I can go and add double quotation to this, similar to this one, but because we have changed the data type by adding the double quotation to date, the data type get changed from date to a string. We need to do the same here to make sure we are uniform over all of the column. Okay, so now the formula been accepted, and if I wanted to show you the result set, okay, so you can see I have 4 columns here. So 2 columns are common, and the other 2 columns coming from the different one. So if I, for example, you can start, so just deselect blank. So those 5 columns that we have are those that they had data in override table. Okay, but this is not enough for our purpose, so we need to do some more work to just get the results that we need for our report. I will keep the first part, that is storing the variable, and then here we will use the same natural left join, but at the result, because we have already changed the data type to a string, we need to use date value to change the data type back to date time. Then we can use some function same as coalesce. That coalesce saying that if the override over this blank is means that the left join wasn't successful, use the working hours from the default value for working hours CT. So actually, with Codex, if this value is not blank, it will use it. Otherwise, it will use the second one. And this is exactly what we need for implementing our logic. Okay, now you can see we have 3 columns. And if we go to the visual, so we should be able to see we have the same values for the override. Okay, so we have implemented override via the calculated table as well. See if we have any question by now. Okay, no question at the moment. Okay, let's see how we can implement this override in the what the third solution is, meaning the calculated column. What we can do, we can create another calculated column and call it working hours override. That giving us the value of the override tables. For example, when we have a bridge table, you want to know that whether this row has been used in override table or not. And for that one, we just need to use calculate and calculate some of the override table, and then filter the override table by using the store code and date based on the values that we have in the bridge table. So it's going row by row, and we calculate this table. And then after that, we need to go and modify the calculated column that we created before. So here, we same as the other solution, we can use Coalesce as well. So Coalesce giving the more priority to the override table. Let's see if you okay, so we create a new column. Sorry, please, some sunshine. Yeah, that's okay. Just have to close it. Okay, so this is the new column for override. Let's go to this one to show you what is happened. So that's the override one, and then for working hours system, so I'm going to use a list of override hours, otherwise 12. Okay, so now you can see we could implement this same as the other two solutions. Okay, and now we go to the fourth scenario when we can use a store schedule. This is actually more close to the reality in the businesses. Most of the businesses want to have this scheduling per store and per day. So for example, here we have a table saying that a store code 01, the working hours based on the day of the week, for example, from Monday to Friday, we have 13 hours for that. So on Saturday it will come to 8 and Sunday to 6. And for 102, we have a different working hours for this one. So you can see every store have a different schedule per each day. Let's see how we can handle it in either of the scenario and which works better for that. For the first scenario that we have for the measure, what we can do, we can create a variable and calculate the sum of the working hours from store schedule and filter the store schedule by day of week that we have in the date table. So in the date table, we have a column called day of week that it is from has a value 1 to 7. And again, using a store code for filtering that. But because here we have to use selected value, and you know that selected value working as the row level, so it just needs to have the unique value. What we can do, we can use this. We can replace the sum of this working hour that we have. We can use this schedule hours variable, replace it to the 12 hours that we have as a default, and it gives us the right answer in the very high granularity. For example, let's say when we are in the store and date level, you can see it's giving us the right value. For example, for Monday to Friday, it gave us 13 hours, but for Saturday 6 and Saturday 6 and 8 and Sunday 6, it is good in the very detailed level. But if you see the aggregated value, the total value showing us the wrong one. The reason for that is because this one, the total value using the filter context, but for calculating the right value for the scheduled hours, we need to force it to go to the row level. So row level on the bridge table, or the row level of the combination of date and store, to go for one store and for each date to find out exactly what is the right working hours for that combination. And yeah, so this filter context measure cannot handle, as I say, in the lower granularity when we wanted to show it, for example, for a month, or we wanted to show this for the older store, so it doesn't work. So this has a limitation and cannot handle this solution, this scenario, sorry. And let me go and quickly show you what happened in implementation. Yeah, so we can see here 56, but it is incorrect. But in the row level, it's working fine. So this solution doesn't work for this purpose when we have the schedule. Let's go to the second solution when we have calculator table. So here, what we can do, so we need to, there is a couple of options for implementing this part to just grab the right working hours from the schedule for each combination of the dates and the store code here. But I wanted to show you this treat as table. So we can use treat as table here, treat as function here, sorry. Treat as is a very beautiful and nice function in DAX. So when you can use it for any unlinked table. So it's working in the way that the first parameters is need to be a table or table function, and the next ones, there are some columns. So it's working in the way that Power BI engine will map the filter that have been used for the first table to the columns to this to the other columns, for example. Let's say, for example, here when we have the I have used summarize. So summarize using a table. The table is this combination that we have for result 1, and then in summarize I have said give me working dates and a store code. But the thing is, this working date and a store code has data lineage to date and a store. So it means that I can use a store code from a store table as a filter for a store schedule, a store code when I use treat as, and same for day of week. So when day of week gets filtered from date table, it can be passed to a store schedule to give us the right number. So this calculate actually working perfect and give us the right value. Just let me to implement it for you. Normally treat that it is very good option when you wanted to use it for budgeting, when the budget table and budget data is not linked to the main dimensions. Okay, so now we can see we perfectly could implement this one. I think the second column, the working hours CT, is result of the calculated column with treat as. So you can see if this is from Monday to Friday, it has really used 13 hours, then 8 and 6. And if you go it for the other shop or other store, that it is 1 or 2. So we can see it's coming with a different number as exists in the schedule. And the total number is worked perfectly as well. Okay. Then we will go to calculated table. In calculated table, so whenever we move further, we feel that it is getting easier and easier implementing the scenarios with the calculated table. Okay, same as before, we just need to create a new column, call it scheduled working hours, and that one filtering the store schedule table based on the day of week and a store code. But because we don't have day of week in the bridge table, we need to do another calculate to give us the value for day of week from the date table based on the working date that we have in the bridge table. And then the second condition is a store code. So by using this, for every row of the bridge table, we are going to have the values from the schedule table. And then we just need to use this new column, just needs to replace the default number that was 12 with this scheduled working hours. Okay, just get the time. Okay, we have 15 minutes more to go. Okay. New column here. And this one, I'm going to replace this with scheduled working hours. So if you notice that by using the calculated column, we are distributing the complexity of the DAX formula over the column. So we are just creating step by step all of our solution, and it's very easier and understandable for the other people. Okay, so you could see here that we have the same result set, same as the calculated table with this, the third solution, the calculated columns. Okay, we still have another scenario. Oh, just been lost. Okay, it is the fifth scenario is when the schedule gets changed over time. Yeah. So, for example, let's say for some specific event of regularly it's happened every year. So the store manager wanted to change the store schedule, but they wanted to keep the history of the data for the past day. They wanted to still see the same result that they had before. So in this case, this is the same as the story changing dimension type 2 in the data warehousing, if you are familiar with that. So what do we have here? We have two more extra column, from date and to date. So this from date and to date telling us that this row, for example, when we say that a store code day of week, for example, on Monday, have 13-hour working days, but it will tell us this is valid between, for example, 1st of July 2019 until 15th of January. And if we have one more set of the column, for example, if we have changed, probably we have the different value from 16 to future date, for example. Let's say, for example, here, the working hours for 101 has changed from 13 to 11, and there was some decrease over the weekend as well. Okay, yeah, that's normally most of the business when you are implementing and modeling. This is need to be considered to just don't override the history of the reports. Okay, as we told, the solution one couldn't be used anymore. We'll go to the second solution. Yeah, here we can't use treat as anymore because treat as is using the column as a direct filter. But here we need to add one more condition to just validate the working days to be between start and from date. So treat as cannot help us, and we can simply go and calculate the working hours from the schedule by filtering the schedule over time. Okay, I have created another table, so this one is a store schedule over time to just have a different set of the data. And yeah, so in the filter we're saying that day of the week should be same as the day of the week by filtering the date and based on the working date, and also the same for a store date. And the two more conditions, we are saying that working dates should be greater than or equal to from date or less or equal to date. So by this one, so we ensure that the formula go and pick one of the rows from the schedule and use it for the calculation. Just go and copy the table. Okay. Just going to replace this part. Oops, hopefully it doesn't break down. Good. Okay, let's go and see the result in the table visual. Okay, so now let's see, for example, for a store 101. It started, let's say we have data from 1st of January, so we have 13 hours and it's included. Just let me to remove the working hours from the measure to make it a bit tidy. Now you can see we are talking about this column, the second column. So if you can see exactly up to 15, we have 13 hours based on the first schedule, and after that you can see we have 11 hours and 6 more here. So exactly it went and found the right schedule based on the history. Okay, now the last part is implementing this in by the calculated column. So that one is very easy. So what we need to do, we just need to, we have the existing column, we call it scheduled working hour we created in the last step. What do we need? We need to go and just add this 2 line as the new condition for that. Just let me to it's not the correct one. I'm looking for the scheduled one. Let's repeat this one. Some scary sounds. Okay. Now we should be able to see the same results for that by just doing this small change. Yeah, that's, we cover all of the scenario with all of the possible options. So because you may say that we can implement this in Power Query or by SQL, that's correct. There is other option by using Power Query and SQL. But here we just talk about the DAX option. So definitely you can go with the other option, but if you wanted to go with DAX, you have this option for implementing this kind of the data in your model. And just to recap, so we went to the different scenarios, different solution. First, we started with the measure. We found it that it is simple, but it is not powerful enough to handle all of the scenarios. Then we went to the calculated column. We could answer all of the questions, but the problem with having all the DAX and formula in one column is just giving us the very long and complex DAX, very hard to understand for the other people and for the other developer. If you want that, it's going to be handed over to somewhere else, or even if for yourself, if you want to get back after some time. Believe me, you can't understand it. Yeah, and it is hard to debug as well. But the calculated column, so when we base the model by using just a small calculated table as a bridge, then just starting creating the logic step by step by using the calculated column is distributing the complexity over the different pieces and give us more flexibility. And it's easy to understand and easy to debug. If you wanted to go, to this model using the calculated column, so we just need to link the calculated column that we created to the 2 table data and store. And the other tables, that same as the non-trading days, override and store schedule, they just get used. They don't need to be linked to the table. They are just helper tables. Okay, let's see, have a look to see if there is any question. Okay, someone asked that, can we take difference for working hours in the time format? Yeah, that's correct. Yes, so because this is at the moment is a number value, but yeah, by using format, you can definitely go and format it, or with DAX you can use you can concatenate the the values, because this is the hours, so definitely we didn't go to in our data example, the data was in hours, but definitely if you, for example, want to go to the minutes or having in the second, so for example, you need to go to calculate in the second level. For example, 1 hour is 3,600 seconds. Then you can divide it and format it same as HHMMSS. Okay, that was the only question. I hope you found this useful. Always have fun with DAX, and please stay in touch with us. Just if you can follow our company on LinkedIn, or we have some monthly training courses for Power BI and also some Power BI consultancy. Thanks again for joining to this webinar, and I'm waiting for your for our next session and training, and hope you can join us. Thank you.